This is the solution to the 2025 GCSE AQA Higher Maths final question. Let's go. So there are n counters in a bag. There are 6 black counters in the bag, 2 of the counters that were selected at random without replacement. The probability of picking 2 black counters is 1/8. We need to find the value of n. So to do this question, we need to draw a probability tree. So we have our first set and our second set. The context of the question refers to a black counter, and we can call this other colour O, just for other colour. So B and then O, B and then O. So there are 6 counters in the bag, so we have 6 over n. It's over n because n is the total possible amount of counters in the bag, and the 6 comes from that there are 6 black counters in the bag. So the key piece of information here is that we have without replacement, so it means we'll have 1 less from the total amount of counters and 1 less from the 6 blacks. So our fraction here will be 6 minus 1 and then n minus 1 for the denominator. So the probability of picking a black and then a black will be 6 over n multiplied by 6 minus 1 over n minus 1. And this is equal to 1/8. Simplifying the left-hand side of this equation, we need to multiply these 2 fractions together. So 6 multiplied by 6 minus 1 over n times n minus 1. And this is equal to 1/8. Expanding the numerator, we get 36 minus 6. And then expanding the denominator, we get n squared minus n. And this is equal to 1/8. Now to solve equations separated by an equal sign, we use cross multiplication. So 36 minus 6 is 30, multiplied by 8 gives us 240. And then n squared minus n times 1 is just n squared minus n. So notice here we have a quadratic, and to solve quadratics, we need the quadratic equal to 0. So if we subtract 240 from either side, we get 0 is equal to n squared minus n minus 240. And now we need to use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a to solve for n. So we're going to do that on the next page. So a is equal to 1, b is equal to minus 1, and c is equal to minus 240. So n is equal to minus b, so minus 1, which becomes a positive, plus or minus the square root of b squared minus 4ac all over 2a, so 2 times 1. So tidying this up, we get 1 plus or minus the square root of 1 minus, now we have 4 times 1 times minus 240. So if we do the grid method to find out what 240 times 4 is, 4 times 2 is 8, add the 2 zeros, 4 times 4 is 16, add a 0, so we get 960. So it is negative 240 times 4, so it's minus 960. These can join to make a positive, all over 2 times 1, which is 2. So this is equal to 1 plus or minus the square root of 961 over 2. Now we need to work out what the square root of 961 is. We know that 30 times 30 is equal to 900. So let's try 31 times 31, as 961 is greater than 900. So if we do the grid method again, to do 31 times 31, 30 times 30 is 900, 30 times 1 is 30, 30, and then 1 times 1 is 1. So we get 961. Therefore, n is equal to 1 plus or minus 31 over 2. So we can either have that n is equal to 1 plus 31 over 2, or n is equal to 1 minus 31 over 2. Now we have to neglect the 1 minus 31 over 2 because this is going to give us a negative answer. And the context of the question said that n was the number of counters in the bag. And we can't have a negative amount of counters in the bag, so we have to take this one here. So 1 plus 31 is 32. So 32 over 2 is equal to 16.